Our lesson for today is all about graphs of linear equations in two variables. Consider the equation 2x plus y is equal to 4. Ordered pairs that satisfy the equation can be found. For example, if y is equal to 0, a value for x, by substituting 0 for y in the equation 2x plus y is equal to 4, can be found as follows. So we have 2x plus 0, which is the value of our y, is equal to 4. And then 2x plus 0 is 2x is equal to 4. And now, let's apply the division property of equality by dividing both sides by 2. 2x divided by 2 is equal to 1x or x. And 4 divided by 2 is 2. Therefore, the value of our x is equal to 2. And for in terms of ordered pair, this is 2 and 0. 2 and 0 is one of the solutions. Other ordered pairs that satisfy the equation are 1 and 2, 0 and 4, 3 and negative 2, and 4 and negative 4. If we're going to plot these ordered pairs in the coordinate plane and draw a straight line, it will show as follows. So let's plot first 2 and 0. Next, 1 and 2. Next, 0 and 4. Next, 3 and negative 2. And last is 4 and negative 4. And after we plot the following coordinates, let's connect the points. And now, this is the graph of our linear equation 2x plus y is equal to 4. The graph of all solutions of 2x plus y is equal to 4 is a line of infinite length as indicated by the arrows in both directions. Now, let's have another example. Let's find three ordered pairs that satisfy the equation y is equal to 2x minus 3, and then graph the equation. For our solution, if x is equal to 0, then y is equal to 2x minus 3. Let's substitute the value of our x by 0. We have y is equal to 2 times 0 minus 3. 2 times 0 is 0 minus 3. And therefore, the difference is negative 3. So therefore, the value of our y is negative 3. In terms of ordered pair, we have 0, which is the value of our x, and negative 3, which is the value of our y. Now, if y is equal to 0, then y is equal to 2x minus 3. Let's substitute the value of y by 0. So we have 0 is equal to 2x minus 3. And then, let's transpose negative 3 to the left side and it will become positive 3 and then is equal to 2x. And next, let's apply the division property of equality by dividing both sides by 2. So 2x divided by 2 is 1x or x. And since we cannot divide 3 by 2, therefore, the value of our x is a fraction, and that is 3 halves. And the ordered pair for this is 3 halves, which is the value of x, and 0, which is the value of our y. Now, if x is equal to 2, then y is equal to 2x minus 3. Let's substitute the value of x by 2. We have y is equal to 2 times 2 minus 3. So we have 2 times 2 is 4 minus 3. Therefore, the difference is 1. And then y is equal to 1. And the ordered pair for this is 2, which is the value of our x, and 1, which is the value of our y. Therefore, 0 and negative 3, 3 halves and 0, and 2 and 1 are some ordered pairs that satisfy the given equations or equation. So let's plot the following coordinates in the Cartesian plane. So we have 0 and negative 3, 3 halves and 0, and 2 and 1. So let's plot first 0 and negative 3. Next, 3 halves and 0. And then the last is 2 and 1. And after we plot the following points, let's connect the following points. And therefore, this is the graph of our y is equal to 2x minus 3. Now, for our second example, let's find at least three ordered pairs that satisfy the equation 3x minus 2y is equal to 6, and then graph the equation on the Cartesian plane. For our solution, if x is equal to 0, then 3x minus 2y is equal to 6. Let's substitute the value of x by 0. We have 3 times 0 minus 2y is equal to 6. So 3 times 0 is 0, and then let's bring down negative 2y is equal to 6. And let's apply the division property of equality by dividing both sides by negative 2. Negative 2y divided by negative 2 is 1y or y, and 6 divided by negative 2 is negative 3. So therefore, the value of our y is negative 3. And the ordered pair for this is 0, which is the value of our x, and negative 3, which is the value of our y. Next, if x is equal to 2, then 3x minus 2y is equal to 6. Let's substitute the value of x by 2. So we have 3 times 2 minus 2y is equal to 6. So 3 times 2 is 6 minus 2y is equal to 6. By applying the additive inverse, so we have negative 2y is equal to 6 minus 6. Negative 2y divided by negative 2 is 1y or y, and 0 divided by negative 2 is 0. So therefore, the value of our y is equal to 0. And the ordered pair for this is 2, which is the value of our x, and 0, which is the value of our y. Next, if x is equal to 4, then 3x minus 2y is equal to 6. So let's substitute the value of x by 4. We have 3 times 4 minus 2y is equal to 6. So 3 times 4 is 12 minus 2y is equal to 6. Next, by applying additive inverse, for positive 12, that is negative 12, we have now negative 2y is equal to 6 minus 12. So, let's bring down negative 2y, and 6 minus 12 is negative 6. By applying division property of equality, let's divide both sides by negative 2. Negative 2y divided by negative 2 is 1y or y, and negative 6 divided by negative 2 is positive 3. And that is y is equal to positive 3. Therefore, the ordered pair for this is 4, which is the value of x, and 3, which is the value of our y. Therefore, 0 and negative 3, 2 and 0, and 4 and 3 are some ordered pairs that satisfy the given equation. Now, let's graph the following points, which is 0 and negative 3, 2 and 0, and 4 and 3. So the plot of the coordinates 0 and negative 3 is this. Next is 2 and 0, and last is 4 and 3. And after we plot the following coordinates, let's connect the following points. And therefore, this is the graph of our 3x minus 2y is equal to 6. I hope you understand our lesson for today, which is the graph of linear equations in two variables.